Now let's just talk about the question number 4. So the question number 4 says, is it possible to design a rectangular park of the perimeter 80 meters and area 400 meters square? If so, then find its breadth and length, or length and breadth. So first of all, as it is given to us that the perimeter of the rectangular park is 80 meter and its area is 400 meters square. So we have to suppose the length and the breadth first. So let's just start the solution of this particular question by taking the assumption of the length and breadth. So let the length of rectangular park be L meters and the breadth of the rectangular park be B meters. So let us suppose if I am taking the length as L and the breadth as B. So according to the question it says the perimeter is nothing but is equal to 80 meters. So we do know about the perimeter of a rectangular field. It is nothing but 2 into L plus B. It is 2 into L plus B, which is equal to 80. And we have taken the length as already L and breadth as already B. So it means this would remain the same. Let's just take 2 towards the other side. So this will be L plus B is equal to 80 by 2, which is nothing but 40. Hence we are getting the equation in terms of L and B is nothing but L plus B is equal to 40. So let us suppose I am calling this equation as equation number 1. Now let's just move on further and talk about the second equation. We will get through the area. It says area is nothing but is equal to 400 meters square. As we know, the area of a rectangular field is nothing but length into breadth, which is equal to 400. So it means L into B is equal to 400. So let us suppose if I am taking it as a second equation. So using the first and second equation, we have to find the value of L and B. But before that, we have to check whether the condition is possible or not. So let us suppose if I am substituting the value of L from here in the second equation. Let us suppose if I am taking L as 40 minus of B. Let's just substitute this into the equation number 2. So this would be 40 minus of B into B, which is equal to 400. Further, this would be 40B minus B square is equal to 400. Let us suppose I am taking these values toward this side. So this would be B square minus 40B and a plus of 400, which is equal to 0. So we are getting this quadratic equation in terms of a variable B at the end of the whole situation. So let's just see whether this is possible or not by checking the discriminant. So as we know, we have the discriminant as B square minus 4AC for the quadratic equation. AX square plus BX plus C is equal to 0. So let us suppose if I'll compare the value of A, B and C over here. So as we can see, we have the variable B over here and we have a constant as B over here. So don't get confused with the constant B and the variable B. Don't get confused, or else you can take the quadratic equation in terms of capital A, B and C as well. So let us suppose instead of taking this equation, I'm comparing the equation with capital A, B and C because of the confusion that will be created after seeing this equation and this equation, because both of these will have a constant or a variable as B. So rather than creating a confusion, I'm taking it as capital A, B, C. So let us suppose if capital A is nothing but 1 over here, I'm comparing these two equations. Furthermore, capital B is nothing but minus of 40 over here, and the capital C is nothing but 400 over here. So if I find the value of discriminant, so discriminant would be B square minus of 4AC type. So this would be nothing but capital B square minus 4 capital AC type. So D would be of the type, if I'm taking the value of B as nothing but minus 40 square, minus 4, 1 and 400. So D is nothing but, this is 1600 minus 1600. So hence D is nothing but is equal to 0. So if the indiscriminate is equal to 0, it means that the roots are real and equal. It means the roots are real and equal. And if the roots are nothing but real and equal, it means that this condition is possible. This condition is totally possible. So it implies this condition is possible, is totally possible. And if it is possible, now let's just find the roots of it. So we know that if capital D is nothing but is equal to 0, then x is nothing but minus b by 2a. They are the roots of the quadratic equation. So in this quadratic equation, we have the variable as b. So it means in place of x, we have b, which is equal to minus of b by 2a. So as we can see, we have minus of b, which is nothing but minus of 40 over here. So this is minus of 40 divided by 2a. A is nothing but 1. So we have the value of b as nothing but 40 by 2, which is nothing but 20. Means at the end we are getting the breadth as nothing but 20 meters. So what would be the length? Let's just substitute the value of b in the length. So we have this equation. Let us suppose I'm calling it as 3. Let's just substitute this value into 3. So L is equal to 40 minus of 20, which is again 20. It implies L is equal to 20 meters and B is equal to 20 meters. So both length and breadth are equal to each other, and hence this is nothing but the answer or the solution set for such a type of a question. So this is all about the sums, which are totally based on the nature of the roots. Moreover, this is the end of our chapter, that is quadratic equation, in which we have studied about the quadratic equations, that what are the quadratic equation, what is the standard form of the quadratic equation, how we can find the roots of a quadratic equation using the three different methods, that is a factorization method, completing the square method, and using the quadratic formula method. And then we have studied the nature of the roots and how we can, or what are the things that we can conclude through the roots of a quadratic equation. So this is the end of our chapter, and now you have to practice more and more question of the quadratic equation all by yourself.